The topic of our capstone group is aluminum CO2 cell for energy generation and CO2 reduction. The problem addressed is the fact that the atmospheric carbon dioxide rate increased by 50% since the Industrial Evolution, which has been about 50 years. The plot on the right shows that the current amount of atmospheric carbon dioxide is at about 420 ppm. Current carbon utilization technologies are costly and inefficient, particularly in the battery energy sector. With this problem, a solution we came up with is a way of carbon reduction, offering a promising solution by enabling sustainable energy storage and providing a cost-effective carbon source for industries. This can support the transition to net zero emissions. Our approach to this problem is to design something that takes CO2 and exports something useful. Then we came up with an electricity generation cell utilizing CO2 as the main source of reaction. On the left is a simplified diagram of the setup. This takes carbon dioxide from a cylinder, which is bubbled into the liquid electrolyte. Then it flows into the cell where CO2 reacts with the aluminum and generates electricity. The remaining electrolyte is flowed back into the flask to be recycled. The video below shows bubbled CO2 and electrolyte flow into the cell. There are several benefits of the solution. First is better energy storage, as aluminum CO2 batteries can store energy more effectively than regular lithium-ion batteries. This makes them especially useful for solar and wind power systems, where energy needs to be stored for times when the natural resources are not provided. Second is CO2 capture and utilization. These batteries help in carbon capture by converting CO2 into a useful product while they work. This means that they can help reduce pollution by taking CO2 from factories or even the air and use it for energy. Third is cost and availability. Aluminum is significantly cheaper than lithium, making them potentially most cost-effective for large-scale production. Aluminum is also more abundant and widely available than lithium, reducing reliance on scarce resources. Lastly, for industrial uses, this battery can be applied in renewable energy, heavy industries like factories that make cement, steel, or chemicals and release a lot of CO2, and innovation and research areas to encourage advancement in electrochemistry, material science, and CO2 reduction technologies.